So we're going to be talking about the systems with abstract coefficients, not just numbers in front of the x's and y's. And we're going to talk about the new kind of variation, linear variation today. So first, one type of abstract system is like this, where you have the coefficients in front of x and y are variables with subscripts. I've still got x and y as my real variables. I have two equations, and they both have x and y in them. So two equations, two unknowns. This is a system that I can follow. These are just going to have messier answers. Now, fortunately, your book will usually not expect you to find both of them and write the ordered pair x comma y. Most of the time, your book is going to say solve for x or solve for y, but they're not going to make you do both. So that's good news, but it also means you better read it carefully. If you go solve for the wrong one, you get it wrong, or you've done a whole bunch of work and then you have to go back and redo it to solve for the other one, even if you catch it at the end. So this one says to solve for x. That means I want to end up, when I've solved my system, x equals something. So if I do elimination, I want to keep x in there. I want to be able to see the x as I go through my work. That means get rid of y. So I'm going to look at b1y and b2y. When I do elimination, I need to end up with the GCF in front for those two coefficients. So my GCF is going to be b1, b2 times y. So that means that I need to multiply my top one by b2, my bottom one by b1, but one of them is going to need to be plus and one of them is going to be minus. It doesn't matter which one I do, so I think I will choose to do the minus first just to get it out of the way, because that's where I usually make more mistakes. So when I do that, and you guys check me with all these subscripts, it's very easy for me to write something down wrong, so let me know if I make an error in there, please. So I get a minus a1 b2 times x, and I get a minus b1 b2 times y, and I get a minus b2 times c1. For the second one, I get an a2 b1 times x, and I get a plus b1 b2 times y, and I get a b1 times c2. So check my work. Do I have any typos in there? Or whatever the equivalent of a typo when you're writing, not typing, might be. Look okay to everybody? Okay, then if this is my system, my y's cancel and I don't have them anymore. I have two things over here times x, so I have a2b1 minus a1b2 times x, and you see I chose to go ahead and factor that x out since I knew that it was in both of those parts. And on this side, I have b1c2 minus b2c1. Now, from other problems you've done where you've solved abstract equations, what do I need to do to get just x, Blake? So I've got to divide both sides by the parentheses. So x is b1c2 minus b2c1 over a2b1 minus a1b2. That look okay to everybody? Now, when you are checking these, there are a whole lot of variations on what the correct answers might look like. If you had done a plus B2 and a minus B1, you would have had B2C1 minus B1C2 over A1B2 minus A2B1. Equivalent, right? You also, on any of these, you might have had C2B1 instead of B1C2. And the same for any of these other pairs. So just check carefully whether it's the odds in the back of the book or the evens when we get to class. There are a lot of variations that are the same thing and that are equivalent. With these, the things to be most careful of. Read it carefully. Are you finding X or are you finding Y? Don't make more work for yourselves. Write carefully and neatly. It is very easy to write a G when you meant a Q. Some of you, your handwriting, some of you, for your D's, you barely go up high. It's very hard to tell if that is a D or an A. So really watch your handwriting for your own sake and for me when checking it. Questions with this one? Let's do one more. This time no subscripts, just a bunch more letters. And these are some of the ones I've got G's and Q's, so I'm going to have to be real careful there. Also make sure I can tell whether it's a T or a plus in some of your work. What are we solving for this time, Lynn? This time we are solving for Y. So I want to keep the Y's or get rid of the Y's? I want to keep them. I want to get rid of the X's. So I need to multiply the top one by F or minus F, the bottom one by Q or minus Q, so that they will cancel out. Again, I usually like to choose negative on the top one while I'm paying my closest attention so that I avoid some of the sign errors. I like to get that part out of the way. That gives me minus FQX minus FRY equals minus FT. For the bottom one, I have plus FQX plus GQY equals HQ. The X's cancel out like we want. That leaves GQ minus FR. Both of those were times Y on the left side, so I can factor out the Y. And that equals HQ minus FT. Emily, what do I need to do now? Emily N. Divide by the parentheses. Y is HQ minus FT over GQ minus FR. Or FT minus HQ over FR minus GQ if you had switched your plus and minus signs for that first step. Questions on these things? Okay, then switching over to the second topic for today has nothing to do with this, linear variation. So we've learned direct variation, inverse variation, joint variation before. So this is going to be another one of those kinds of situations, those types of problems. When you hear linear, what does that mean? That's a line. And tell me about the equation of a line. What's your favorite form? Y equals mx plus b. So linear variation ones are going to be of the form y equals mx plus b. So if this had been y varies linearly with x, we would have started out with y equals. If it were p varies linearly with q, we would start out with p equals. When you had your direct variation, your inverse, or your joint variation, whatever they said, m varies, you started off with m equals, right? Then you did k for your constant of variation. Now we're doing m. If you have a line, any line you want, does the slope ever change on that line? If it is a straight line, if it's linear, the slope is the same no matter where you are on the line. So the slope is your constant of variation when it is linear variation. It's just we're used to y equals mx plus b, so that's what we're going to use on this one. So if it were y varies linearly, it would be mx plus b. C varies with n, it's mn plus b. P varies as p equals linearly with n, or with q, it's mq plus b. Now, if I had y equals mx plus 0, that's a y equals mx plus b, b's just 0. Y-intercept is 0. My line looks something like this. Instead of m, if I happen to use k, the slope would have been the constant of variation. Direct variation, y equals kx, is a special case of linear variation. It just has the y-intercept of 0. It just goes through the origin. Does that much make sense so far? Okay, let's try one example problem and then we'll work on homework stuff. So the total cost varied linearly with the number produced. So first thing I'm going to do is decide my variables. I'm going to choose to call this C and this N. You could have used T for total cost. You could have used P for produced, but decide what your variables are. Varies linearly. So C varies. All variation problems, whatever that first variable is, C varies, means we start off with C equals. Okay, this one has to fit mx plus b, except my second variable is not x, it is n. So that is my pattern for this problem. When you have done direct, inverse, and joint variation problems, you've had one example, one case 1, and then they've given you part of case 2 and asked you to find what's missing. So they more or less do the same thing here. Here is case 1. 100 were produced, so that's the number produced. The cost was 700. And we have that. How many variables are in that problem now? 2. Can you solve one equation for 2 unknowns? So we need a second equation. So linear variation is going to have to give you 2 cases before they can ask you about a third case to find something that's missing. So second case is 400 were produced. The cost was 2,200. Now, because these are linear variation, they're always going to end with plus b. So your easiest way is going to be elimination. Multiply one of those by -1 so the b's cancel out. So I am going to multiply this first one by -1 so that I have minus 700 is minus m times 100 minus b, giving me what? 1,500 is, and I'll get my number in front of the m this time, 300m, and the b's have canceled out. So Emily B, what's m? So far I know that my pattern for these problems is C equals 5n plus, and I don't know what b is yet. Like any system, two variables, two equations. We solve for one variable. We substitute back in. I'm going to substitute back into that green equation. 700 is 500 plus b. So what is b, everybody? So whenever it says write an equation that gives cost as a function of the number produced, that means you must get an equation like that that has cost and number produced as the variables in there, and the other things in there are numbers. And I'm going to give you the case 3 for this. We're not finished with this problem yet. I'm going to give you the case 3 that we're going to solve in a minute. You cannot jump straight to that. You've got to write it with the variables in it like this, or you don't get the full credit on it. Now I want to talk a little bit about what this means. We weren't asked to do that on this problem, but c equals 5n plus 200 means I have a y-intercept of 200, and I have a slope of 5. So my line's going up like that, and here's my cost, and here's my number produced. That means I have the point 0, 200 on there. Make sense out of that point for me in the context of this problem. So 0, that's this variable over here. That's n's. That's the number produced. So if I don't make any, the cost is 200. I'm right here making none, and the cost is 200. When I make 1, it's more than that, and so on. How can that happen? How can I not make anything? Why would I have a cost of 200 if I haven't even made anything yet? Eden?
Maybe to like buy supplies to make this stuff.
Maybe to buy supplies. So maybe I'm just going to, I don't know, make some jewelry at home or something. And maybe I need the right kinds of tools and beads and silver and whatever. I'm probably not going to pay them until they start making something. Maybe I do. Maybe I need to pay some to get a factory set up. What else might I have to pay for? Taxes probably not till after I've started having a profit and having some income. Maybe I have to rent a factory or build a factory or buy machinery for that. It'd be a whole lot more than $200 in that case, but I could have an initial cost. So that means 200 is the initial cost just to get started. Often called startup cost for starting a business. So I wanted to illustrate that because you will have some questions, SATs, ACTs, that are asking you to interpret graphs in different ways. It may or may not be a startup cost, but it's going to say, what does this place on this graph mean? So you're going to look at, well, the first coordinate is n. What's n in the problem? The second coordinate is c. What's that in the problem? What does it mean when n is this much and c is this much to put those together? Does that kind of make sense for that reasoning? Okay, part B of this problem now is what is the cost if 250 are produced? What do I do to get that? Ronald, what?
You put 250 instead of that.
Okay, 250 is the number produced, so I put that right here. I want to get the cost, so the cost is going to be 5 times 250 plus 200, or 1250 plus 200. Did I do that right? So $1,450. And you will have most problems that ask you to do things like that. The book will not ask you about drawing the graph and explaining the y-intercept. I may sometimes add some of those kinds of things in just to challenge you to think about it and interpret your results. Anybody with any questions for me?